Saxon Algebra 1/2 lesson 50. Are you ready to feel smart? We are going to play around with a topic called scientific notation. We'll come back to this topic again and again and again over your years of high school mathematics. This is a process that is super useful in the sciences, in either physics or chemistry, where numbers are sometimes very, 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 very small, going up to physics and astronomy both, are physics and chemistry both, but astronomy is the one where this is really useful because we have very big numbers. So scientific notation is good for very large and very small numbers. You can use it for any size numbers, but it's just particularly good in the calculations where we have just like gigantic numbers and we don't want to write a zillion zeros. And like I said, it's very popular in the sciences, thus the name. And so when you learn this, you're doing yourself a favor because when you get to those science classes, it's going to be way easier because you're already going to understand how to do the math of them. All right, we're going to start. I'm going to teach this to you in a couple different ways, and then we'll streamline it and get a process down, and then I'll write down the steps of that process. But I want you to understand it before I try to lay out the steps. Let's take a process you're familiar with. We have done this process before of saying this number is equal to 7 times 1 million, right? Because this is 7 in the millions place. And so we can rewrite this number as 7 times 1 million. We've done that. I think we did that at the beginning of this class, but I'm sure you've done it in your math history. Now, we can also write this number as an exponent, right? We know that we can write this as a power of 10. Every 0 represents another number in the exponent. So we count the zeros, 1, 2, 3, 4, 5, 6. So we can write 7 million as 7 times 1 million, and then we can write the million as 10 to the 6th, right? You just count up the number of zeros, and that tells you the exponent. We're going to use these two shortcuts to help us create scientific notation, which, by the way, that is scientific notation. That's the way we want all our numbers in scientific notation to look. And here we have the largest digit in the ones place, or the units place, as we sometimes call it. And then we multiply that by a power of 10. That's what makes for scientific notation, is that we're going to write it like that. And as you can see, it's much neater than writing out all the zeros. And the bigger this gets, the more happy we are to write it that way. Now, in this example, our number isn't 7 million exactly. It's 7,024,000. So we're going to follow this same process, but instead of just having a single digit of 7, we're going to write it as 7.024 times 10. Oh, no, I don't want to say 10. Okay, times 1 million, just like we did here. Right? Because this is 7.024 times 1 million. That's the same as this. Now we've got this number how we want it, 7.024, but we want to write this as a power of 10. So we write 10 and we count the zeros, 1, 2, 3, 4, 5, 6. And that is the right answer. Let me just see how many examples we have. Just 2. Okay. All right, so let's do another one. Example 50.2. This time the number that we're starting with is 476.23. Okay. Now, in this one, we rewrote it as a power of 10 and we wrote that number out. This time we're going to simplify that step. And here's what we're going to do. Instead of finding this number, we're just going to move the decimal place, which is the same, right, as multiplying. We don't want the decimal place to be there. We want it to be right here. So that tells us our number is going to be 4.7623. And we have to multiply it by a number that is the same as the number of jumps. 2. Now that's the very same thing that we did here. Let's look at this one. Here we had the decimal place was originally there. 1, 2, 3, 4, 5, 6. We wanted it to be right there, right? And that's what we got, 7.24. And instead of writing it this way, we can write 10 to the number of jumps. 1, 2, 3, 4, 5, 6. So that's the process we're going to use now. This is conceptually how we understand it, but we can streamline this process a little bit. And when we look at our final answer here, what this tells us is to get our original number back, we would take this number and multiply it by 10 squared or 100. If we multiply it by 100, that would move the decimal twice that way and put it there, and that's our original number back, right? Because it was 476. That was the original decimal. So this tells us to make the number in scientific notation bigger by multiplying it by 100, which moves the decimal 2 jumps to make the number bigger. So it would go boom, boom, all right? Don't think of it in terms of left and right. Think of it as whether the exponent is making this number get bigger or get smaller. And a positive exponent makes this number get bigger because multiplying by 100 makes something get bigger. I'm going into details to explain all that to you because now I'm going to make it a little more confusing. That's my job, right? And I do it well. Example 50.3 involves numbers that are smaller than 1. Right? This number is less than 1. So when we move the decimal, we still want to get the decimal so that there's just one digit in the ones place. The biggest digit, we call it the significant digit, the largest significant digit, which means don't worry about zeros. We want that to be in the ones place. So we want to move it 1, 2 times. That will give us 6.52 times 10. We moved it 2 jumps, so we want a 2 there, but we want to make this number smaller. We don't want to multiply it by 100. We want to multiply it by 1 over 100, essentially, right? Because that will make it get smaller. So what we do is we put a minus sign there. Okay? So when we have a number written in this format and we want to make it smaller, we put a minus sign up there. And let's do one more of this style. This is a cheater style because John has an A and a B. So A says write these numbers in standard notation. 4.6 times 10 to the minus 4. Okay, so what we're getting now is we're getting the scientific notation and we have to create the number again. So what I'm going to do, just to give myself a little more room, I'm going to write 4.6 right there. And I'm going to look at what this message tells us. This says, move the decimal place 4 times to make the original number smaller. Okay, so this is the number of jumps. And the minus sign tells us make it smaller. Okay, so to make it smaller, we're going to move the decimal this way. 1, 2, 3, 4. There's the new decimal. What do we do about these? Fill them in with zeros. Okay, so our new number is 0.00046. You would not have to rewrite that in your homework. This would be fine. I would accept this on a test as well, but I just want to be super neat and clear. All right, so that's how we take a number with a minus exponent and put it back into the standard form. We call this standard notation. It's a regular number. Okay, and we call this scientific notation. Okay, so that will help you remember what John is asking you to do. And then the last problem for this lesson is the part B. He wants us to write this number in standard notation too. 4.6 times 10 to the 4th. Okay, so this tells us that we're going to make we're going to jump the decimal place 4 times. There's an invisible plus sign there, so that means make it bigger. So I'm going to write the 4.6, and then I'm going to move the decimal to make it bigger, so that's this way. 1, 2, 3, 4. And that means our final answer is 46,000. Okay? Now, in case you have ever had in the past or will in the future have a teacher that likes to talk about scientific notation in terms of moving the decimal to the left or the right, I want you to block that out. Do not listen to that right or left talk, because it doesn't make sense if you, I don't even want to tell you how it doesn't make sense, but it's incredibly confusing. Well, the question you want to ask yourself is, are you trying to make your number bigger, larger, or smaller? Greater or lesser, whatever the mathematically correct terms are. Think of it in terms of how you want to change the value of the number. If there's a minus sign, that means that you're taking jumps that make the number smaller. If there's a positive exponent, that means you're taking jumps that make the number bigger. All right? We're going to work on this a lot. So if you feel a little bit horsewhipped right now, and I don't even know how it feels to be horsewhipped, but I don't think it's good. But if you feel a little crazy right now, don't worry. We're going to work on this for a long time, and we're going to take it nice and easy. Thank you, students. Lesson 50 is done. Enjoy your homework.